When you think about cybersecurity threats, you'd probably imagine massive corporate data breaches, ransomware attacks on hospitals, or state-sponsored hackers targeting governments. What most people don't imagine is something quieter but potentially just as dangerous. Hundreds of thousands of Linux devices sitting exposed on the public internet, silently waiting to be scanned, probed, and possibly exploited. The number is staggering, around 800,000 devices. That's not a small lab experiment or a niche issue. That's nearly 1 million systems, many of them running critical services, reachable by anyone with an internet connection. To understand how serious this is, we first need to understand what exposed really means. In cybersecurity terms, exposure usually refers to services that are directly accessible from the public internet without adequate protection. This could mean open SSH ports, misconfigured web servers, unsecured databases, outdated control panels, or management interfaces that were never meant to be publicly reachable. Linux powers a massive portion of the internet's infrastructure, from cloud servers to embedded devices, from routers to industrial systems. When these devices are exposed improperly, they become low-hanging fruit for attackers. The number 800,000 doesn't come from thin air. Security researchers routinely scan the internet using tools that map open ports and services. Platforms like Shodan and Senses index publicly accessible devices and services, effectively acting like search engines for exposed systems. When researchers query these databases for specific vulnerable versions of software, misconfigured services, or default credentials, the results can be shocking. It's not unusual to find hundreds of thousands of devices running outdated Linux kernels, unpatched web servers, or administrative interfaces that should never have been accessible. One of the most common exposure points is SSH, the Secure Shell Protocol. SSH is essential for remote management of Linux systems. Administrators rely on it daily to manage servers, deploy applications, and monitor systems. But when SSH is left exposed to the internet without proper configuration, it becomes a constant target. Attackers use automated bots to scan IP ranges and attempt brute force logins using common username and password combinations. Even if the system isn't immediately compromised, the constant login attempts create log noise and increase the risk of eventual success if weak credentials are used. Another major exposure vector is outdated web applications running on Linux servers. Content management systems, control panels, and custom web apps often rely on Linux as the underlying operating system. If these applications are not regularly updated, known vulnerabilities can be exploited remotely. Attackers don't need to invent new techniques. They simply use publicly available exploit code targeting known vulnerabilities that haven't been patched. Misconfigured databases are another alarming issue. There have been numerous cases where MongoDB, MySQL, or Redis instances were left open to the internet without authentication. In some instances, attackers didn't even need to exploit a vulnerability. They simply connected and accessed or deleted data because there was no password set. These incidents often make headlines when exposed databases contain sensitive customer information, internal logs, or proprietary data. But the exposure problem goes beyond traditional servers. Linux is deeply embedded in devices most people don't think about: network routers, security cameras, smart TVs, industrial controllers, and IoT devices. Many of these devices run stripped-down Linux distributions customized by manufacturers. The problem is that once these devices are deployed, they often receive little to no updates. Users may not even know how to update them. If a vulnerability is discovered, thousands or millions of devices may remain exposed indefinitely. Consider a small business that installs a Linux-based firewall appliance. The device is configured once and then largely forgotten. It sits in a rack, quietly routing traffic. Over time, vulnerabilities are discovered in its web management interface. If the business never updates the firmware and leaves the management interface exposed, it becomes part of that growing number of exposed systems. Multiply this scenario by thousands of small businesses worldwide, and you begin to see how the number 800,000 becomes plausible. Cloud infrastructure adds another dimension. Many organizations spin up Linux virtual machines in cloud environments for testing or temporary projects. These instances may have public IP addresses and open ports during development. When the project ends, the instance might be forgotten, but not properly shut down. It continues running, exposed to the internet, potentially with default credentials or debug services enabled. Over time, Abandoned cloud instances contribute significantly to the pool of exposed devices. One particularly dangerous exposure type involves remote desktop or management interfaces. Some administrators expose web-based control panels directly to the internet for convenience. These panels may allow full server control, including file management, database access, and service configuration. They're protected only by a weak password or outdated authentication method. They become prime targets. Attackers can gain full system control in minutes if successful. The consequences of such exposure vary. In some cases, attackers use compromised Linux devices to deploy cryptominers. These programs hijack system resources to mine cryptocurrency, generating revenue for the attacker while slowing down the device. In other cases, compromised systems are added to botnets. Botnets are networks of infected devices controlled remotely to launch distributed denial-of-service attacks or send spam. A single vulnerable Linux device may not seem significant, but when aggregated into a botnet of thousands, the impact can be massive. There is also the risk of data theft. If an exposed device stores sensitive information, attackers can exfiltrate that data and sell it or use it for further attacks. For example, if a Linux server hosts an application containing user credentials, and those credentials are not properly hashed or protected, a breach can expose thousands of accounts. Even if passwords are hashed, attackers may attempt offline cracking if they obtain the database. Ransomware targeting Linux systems is also becoming more common. While historically ransomware focused on Windows systems, attackers increasingly recognize the value of Linux servers. Encrypting a Linux-based file server or database server can cripple an organization. If backups are not properly maintained or segmented, recovery becomes extremely difficult. One reason so many Linux devices remain exposed is the misconception that Linux is inherently secure. While Linux has strong security features and a robust permission model, it is not invulnerable. Security depends heavily on configuration, maintenance, and updates. A misconfigured Linux server can be just as vulnerable as any other system. Another factor is skill gaps. Not every organization has dedicated security professionals. Small businesses, startups, and individual developers may deploy Linux systems without fully understanding the implications of exposing services to the internet. Tutorials often focus on functionality rather than security hardening. A developer might follow steps to deploy a web app, but skip firewall configuration or fail to ban setup, leaving services unnecessarily accessible. Automation cuts both ways. Attackers use automated scanning tools to discover exposed devices quickly. Within minutes of a device connecting to the internet with an open port, it can be detected and added to scanning databases. Attackers don't need to target specific victims manually. They'll let scripts do the work, probing thousands of IP addresses per hour. If a vulnerability is found, exploitation can be automated as well. Firewalls are often misconfigured or too permissive. Some administrators open ports temporarily for testing and forget to close them. Others rely solely on network-level firewalls without configuring host-based firewalls like iptables or enfables. Defense in depth is often missing, leaving a single layer of protection between an exposed service and the public internet. Password reuse is another serious issue. Even if SSH is protected with strong encryption, using weak or reused passwords undermines its security. Attackers maintain large credential databases from previous breaches and use them in automated login attempts. If an administrator reused a password from another compromised service, an exposed Linux server could fall quickly. Outdated kernels and software versions compound the risk. Linux distributions regularly release security patches. However, if systems are not updated promptly, they remain vulnerable to known exploits. In some environments, updates are delayed due to fear of breaking production systems. While caution is understandable, indefinitely postponing updates increases exposure. Secure configuration frameworks exist to mitigate these risks. Tools like fail2ban can block IP addresses after repeated failed login attempts. CVSS can be configured to use key-based authentication instead of passwords. Firewalls can restrict access to specific IP ranges. Services can be bound to local hosts rather than public interfaces. Yet these measures are not universally applied. The scale of 800,000 exposed devices suggests a systemic issue rather than isolated negligence. It reflects a global ecosystem where convenience often outweighs security. It highlights the tension between accessibility and protection. Remote management is convenient. Public APIs are necessary. Cloud scalability requires openness, but each opening must be carefully controlled. There is also an educational gap. Many people deploying Linux systems are self-taught. They learn through blogs, forums, and videos. While the open source community provides tremendous resources, security best practices are not always emphasized enough. Beginners may not realize that exposing a service to 0.0.0.0 means it is accessible from anywhere. Governments and cybersecurity agencies frequently warn about exposed devices, but awareness doesn't always translate into action. Some organizations underestimate their risk profile, assuming attackers won't target them specifically. However, automated scanning doesn't discriminate. If a device is vulnerable, it becomes a target regardless of its size or importance. Mitigating this crisis requires layered solutions. At the individual level, administrators must adopt strong security practices. At the organizational level, regular audits and vulnerability scanning are essential. At the industry level, manufacturers of Linux-based devices must prioritize secure defaults. Devices should ship with strong authentication requirements and closed management interfaces by default. Cloud providers have also introduced security groups and network access controls to reduce exposure. However, misconfiguration remains common. Infrastructure as code can help standardize secure deployments, but it must be written with security in mind. The number 800,000 should serve as a wake-up call rather than a statistic. It represents real systems, real data, and real risks. Some of those devices belong to small businesses that could be financially devastated by a breach. Others belong to hospitals, educational institutions, or critical infrastructure providers. Cybersecurity is not about paranoia. It is about responsibility. Every exposed device is a potential stepping stone for attackers. Even if the device itself doesn't contain sensitive data, it can be used as part of a larger attack chain. Compromised devices can scan internal networks, escalate privileges, and pivot to more valuable targets. The Linux ecosystem is powerful and flexible, but with power comes responsibility. Administrators must treat internet exposure as a deliberate decision, not a default setting. Every open port should have a clear justification. Every public service should be hardened. Every system should be monitored. The story of 800,000 exposed devices is not just about numbers. It's about habits, awareness, and the evolving landscape of digital infrastructure. As more devices connect to the internet, the attack surface grows. Without proactive security measures, exposure will continue to rise. But this situation is not hopeless. Linux provides the tools necessary for strong security. Firewalls, access controls, logging systems, encryption frameworks, they are all available and mature. The challenge lies in consistent implementation. Ultimately, the warning is clear. If you run a Linux system connected to the internet, you must assume it is being scanned constantly. You must assume attackers are probing for weaknesses. Security cannot be an afterthought, because somewhere within that number 800,000 exposed devices, there could be one that belongs to you.